Okay, now we shall try to design for recambering. Now for recambering, you have to have three alignments. One is our design alignment, other is these two, that is existing tires. Okay, so for this existing tires, you can make them alignment. It is very easy. You don't want to draw. That is one good thing that you have in Civil 3D. So for that, you can go to alignments, create alignment from polyline. Alignments, create alignment from polyline, and they say select the first line. So I'll select this. Now if you cannot select this one like this, if you cannot select this one like this, what does that mean? It's not a polyline. So we will have to make it polyline first. There is a small method for you to do that. You select these two, right click, isolate objects, isolate selected objects. You are going to make it isolate, right? Then you are going to explode it. Okay, how do you explode it? There may be some tool bit, I don't remember, but what I usually do is I type, okay, explode, right? Select objects, I select them like this and press enter. Now if you select this one, you see it is a segment, it's not a polyline. Again, now I have to make them polylines. How? There is a method PE, that is p-edit or polyline edit. Enter. Before that you have to make them, you have to flatten them. Okay, make them into, bring them into the zero plane. For that you have to enter flatten. Flatten, select objects, select everything, press enter. Remove hidden lines, no is selected, press enter, right? Then we are going to give PE command. PE, select polyline or multiple, because so many segments. M, enter, select objects. Now I am going to select it and press enter. Convert lines, arcs and splines to polylines. Yes, no. Yes, yes is selected, press enter. And I have to give join, J, enter. Enter first distance, that is 0 selected, press enter and then press escape. So you can see that these two are being made polylines. Okay, now right click, isolate objects, end object isolation, so your whole drawing will be visible, right? After that you can make them alignments. Alignments, create alignment by polyline, select the first line of polyline, this one, right? Now it's been selected, can you see? Press enter. Press enter to accept alignment direction. Now alignment direction is, you just think that it can be from here to here or other way around, but if I start it from the beginning, it usually from here to this way. Okay, so press enter. Now you give the name. Name is ELHS, type is offset, site is site 1, alignment style, this should be RD something. Alignment label set means the chain edges. We don't want to give chain edges, no labels. Untick add curves between tangents. Untick erase existing entries. Otherwise, what happens is your tires will be deleted. Okay, then press OK. Can you see that alignment is being created? It is ELHS. Now you have to create ERHS in the same manner. Alignments, create alignment from polyline. Select the first line of the polyline, select, press enter. Do you want to change the direction? No. Then press enter. Give the name ERHS. Type is offset. Site is site 1. No labels, okay. Untick add curves. Untick erase existing entities. Now press ok. Now you have three alignments. What are they? DCL, ELHS and ERHS, right? Now I am going to create the recambering surface. Save the drawing. For that, you want to have a corridor, recambering corridor. Okay. Before creating the corridor, you have to create an assembly. Assembly is something that you are giving. You are giving the software some details. So your the thickness should be there. This thickness should be this much. The width should be this much. All these details we are giving to the software using what? An assembly. Okay. So you can go to corridors, create assembly. Corridors, create assembly. And then give the assembly name. Usually I give RC, that is for recambering. Assembly type should be undivided crown rod. Undivided crown rod. Undivided means there is no center median. Crown means your rod is like this with a crown. Okay. Otherwise there can be a flat rod also. That we call planar. Okay. And assembly style, you have to take the RDA style. Code set style, again RDA style. Then press OK. Specify assembly baseline location. I am going to put it somewhere here near this profile view, because otherwise I can't find it because it's so small. Okay. And another thing you can do is you can draw a circle around it. Right. Now this is the baseline or the center line. Now you are going to fill it. For that you have to go to general tool palettes window, and here if you right click here, there will be new rehab or rehab, whatever. I have to take rehab, I think, not new rehab. Yeah, we have to take overlay mill and level 2 and select marker point within assembly. So I'm going to select it, escape, and then you select this one, right click, sub assembly properties. Okay, then you go to parameters. You have to fill these details. What do they ask? Crown point offset, whether that your assembly should have an offset with the existing, no, not the existing design center line. How can this happen? Because you know it is not always your alignment. So your crown need not to be always like this. It can be like this also. Okay, even though there is no separation, it can be like this also. That is what they are asking. So it is 0. Left sample, remember left is always minus. Anywhere if you see the word sample, what they are asking is about the design center, so the design aspects. Okay, so this is the design lane width they are asking. So it should be minus 3.5. Understand? Remember, anywhere you see left, it should be minus. If it is sample, they are asking about design details. Okay, right sample, right should be always plus sample. Then trim. Anywhere if you see trim, what they are asking is the existing one. So we don't know, but we are just giving some value in order to draw it, nothing else. Okay, so because it varies, here it may be minus 2.5, somewhere here it may be 2, or somewhere here maybe somewhere there it may be say 3, we don't know, but we just give, remember it is left, right, minus 2.5. Right trim point offset, right plus 2.5. Then left overlay slope options, you have to give outside lane superelevation. Default left overlay slope, because if there is no superelevation, what is the default that he has to take? It's minus 2.5. And right overlay slope option, it is outside lane superelevation. Default right overlay slope, it is minus 2.5. Slope tolerance, you have to give 0. That means there is no tolerance about the slopes. It has to take whatever slope we take. No slope tolerance. Okay. 0. And use profile, here you have to give use minimum clearance. Remember, now in this case, for the recambering only, we are changing use profile into use minimum clearance. But for your design, when you are going to draw the cross sections, you have to give it as use profile here. Okay, there are two options, use profile and use minimum clearance. Here we give minimum clearance. Why? Because we want to check, we are giving the minimum clearance and then we are going to run it. Okay. Then minimum clearance is whatever that you are having other than the asphalt layers. Okay, so we'll say 250 ABC. If you had say some soil also, uh, if you had some 300 millimeter soil also, then this should be 550. Okay, then the overlay depth is 50-50. Of course, the pavement design has to come to you. Since we don't have, we are just assuming, right? So it should be 100, right? Then okay. So press apply and press OK. Now can you see, this is what they are going to draw. So in your case, you will not get this much of a beautiful one, because you know, now in your case, this RDA one is not for creating cross sections. It is for creating, the RDA template is for creating the plan and profile. So if you get the cross section one, you will be getting beautiful pictures like this. Okay, then save. Right, now we will create the corridor. Okay, we will create the corridor. For that, you go to corridors, create corridor, and usually I give the corridor name as RC, that is for recambering. Whatever the name you want to use, you can use. Corridor style is basic, and baseline and type alignment profile. Alignment should be DCL, the one that we use for the center line, and profile is EG surface. Assembly is RC that we created, and target surface is EG. Okay, check whether everything is okay. Name is RC. Okay, corridor style is basic, baseline type is alignment and profile. Okay, alignment is DCL, profile is EG, assembly is RC, target surface is EG. Now it is going to run. Press OK. Now assembly is RC, start station is 0, end station is this N1, and then the frequencies, of course, we have to give. Now everywhere we have taken in roughly in 10 meter intervals. Okay, so we are just going to give everywhere 10 meter. Curve increment also, because if you want to have say for the curve increments, maybe you can ask your surveyor to take in 5 meter intervals. If you took 5 meter intervals, give here 5 meter, otherwise just put 10. Okay, along spirals, we don't have spirals. At horizontal geometry points, if you haven't taken levels, at horizontal geometry point, there is no point keeping it as yes, because it all depends upon the levels, whether you have or not taken the levels. So we give it no. Super elevation critical points, if you have taken levels, keep it as yes, otherwise no. Along vertical curves, same thing. And 10 vertical geometry points, we didn't take levels. At high low points, we didn't take levels. Didn't take levels in the sense, specifically for these places, we didn't take levels. We just took by 10 meter intervals. Understand what I'm telling? Then at offset target geometry, no. Adjacent to offset target, no. Okay, and then you have to give the targets. Round offset target. left trim, crown offset targets here. Maybe if your version is different, you will get some other thing, right? Here in my case, this is the first time I saw this. Okay, otherwise what it comes is here you have to change. Okay, here you have to change your alignment, and then crown offset target, that should be DCL, right? Then left sample, of course we are not going to give. Left trim, it should be ELHS. Right trim, it should be ERHS. Now here there is a there is an option to select feature lines also, that we are not going to touch. We are going to give only the alignment. Now check crown offset, it should be DCL. In your case it may be somewhere here, right? Left sample, left trim ELHS, right trim ERHS. Okay. What is this region? Side. Yeah, I will press OK. Press apply. Rebuild the corridor. OK. Now check whether your corridor has been created. It seems it has been created, like OK. Now your corridor is being created, but you have to have the top surface of that corridor. Top surface of that corridor. For that, what you are going to do is general tool space. You go to prospector, corridors, RC, properties, and here in the surfaces you go and add here, create a corridor surface. Data type should be links. Specify code is top. That means you are going to create the topmost corridor, topmost surface. Okay, add it, apply. Okay, so this is that surface. Now of course if you want, you can just change that surface properties, contour points and triangles and borders. Now can you see, now this is your topmost corridor surface. Now what you are going to do is you are going to add it here. For that it is easy. Profiles, create profile from surface. Now you can see under DCL, earlier it was only EG, now we are having another surface, RC3, that is the one we created. So you have to add it, and then rather than going for draw in profile view, you have to press OK. Now can you see, this is your recambering surface. So it has considered all the recambering record. Right. Now your task is to design as much as possible to this recambering surface. Save the drawing. So we will do that design also for the profile design. Profiles, create this time it is create profile by layout. Select profile view to create profile. Right, name usually I give FG. Profile style you have to select the RDA1. Profile label style also same. Press OK. Again, like in the alignment, you are getting a toolbar. Okay, but here what you have to do is you have to select draw tangents and draw tangents first. Now remember, if it is 50 kmph, what should be your curve length? The vertical curve length 50, right? Should be 50. So you have to keep them somewhere. You can provide 50, otherwise don't put it like this very nearby. Okay, so I'll just put like this, as much as possible to the recambering surface. Here there's going to be a fill, it seems. And there are few things that you have to keep in mind, okay, when you're going to design this one. What are they? One thing is drainage consideration, okay. So your gradient should not be lesser than how much? 0.3%. Yeah. And what else? The K values. Okay, now just think, now this is a rough one, okay, this is some rough one. So we'll try to have some profile that is say as much as possible to the recambering surface. So here I am going to give a curve of 50 meters. For that you can go to more free vertical curves, free vertical parabola, PVI based, and it says PVI, pick point near PVI here. So I'm going to give 50. Then you can't have an IP here. Can you understand? Can't have an IP here. So you have to delete it using, don't just click and delete. Then everything will be gone. Okay, you have to use these tools. Delete PVI. Now what happens? So it seems there is going to be a field here. Should you be worried about that? No, you need not to be worried if you have done it correct. Because if you are going to match it exactly onto this one, of course there is no design you have to do. The road is already designed. You have to go for cutting and filling because the road is not designed. Okay, so don't worry. Here what I can do is, okay, so I can say I can take it down here up to the start point. Okay, using here, say I'll give 25 here and then try. Then this is 50. One thing you have to, here you can see it is only in 20 meter interval. So you can go to edit profile view style and go to horizontal axis and give this interval as 10. Okay, then it is bit easy for you. Okay, because then you can consider the levels and everything. Right, then you have to have some IP at 75. Can you understand why? Because it ends here, so you can start somewhere from 75. So I'll give somewhere here in 75. Okay, then you will have to remove this one. If it is 75, the other one has to come in 125. Understood? Otherwise you can't have a curve, right? This should be 125. Okay, now here we are going to put 50 and I am going to put here also 50. Then of course you can't have an IP here. Okay, so you have to have the IP somewhere, say 175 only you can have the IP. 175, and the next one should be 225, right? 225. Then I am going to put 50 here, again another 50. Then you can have the other one in 275. Later we'll correct these things, right? I'm just drawing something to match with the existing yeah. So here you can take if you want, you can drag this here also. Say through 325, and let us have 50 here. Now let's take this into say 405 and 50 here, and here 455. Here you don't want to have any IP. Can you see? Minus 42 minus 44. So you can just remove it. Okay, and then 498 we'll take it as 500, and then we'll give 50. Now you can't have this one. Can you see why? It is 0.08. There will be drainage problem, right? So I think we can remove this as well. Where does it come? And we can remove this as well. 0.21. 0.21 is not going to work. You have to have minimum 3%. So we'll take this here, 680, 680, and what you can do is you can insert an IP here, somewhere here, and you can make it say 0.3%. Now what happened here? 0.3%. This becomes 0.1. What if I give? It should be 100, 610. Yeah, 0.3%. And if I give here minus 3%, what happens? And I'm going to have a say 550, and I'm going to have a 50 curve here. Here 0.31, I'll reduce it back to minus 0.3, and minus 0.3 plus 0.3, that's pretty okay. So we'll have 50, and here of course we can have 50, and then I have to take this here 730, 30, and you can't have this one. So what you can do is you can shift it here along this line. Yeah. So you should have good eyesight. Okay, good eyesight to do this. Why you have to go along this curve. Say 760. Oh, it seems pretty okay, but 760, and you have to have another 100 here, that is 860. No, so you can't have it here. Say I'll put it somewhere like 810. Okay, then this has to be 710, right? Minimum 710. Oh, what happened? No, no, this is okay. You want only 50, right? So I'm going to get here 50 and here 50. Okay, and you can't obviously have this one. Instead, you will have to have somewhere here 860, and then we'll have 50 here. Okay, now can you see that there is some filling here? You can't avoid it. Try it, but sometimes may be possible, because there is no hard and fast rule. There's no hard and fast rule. So sometimes I do one design, you do another design. Maybe your one may be better. That depends on how much attention and how much competence that you are going to put into this design. Nothing else. Okay. Even a very competent person, he comes and do very quickly. He does a design that may not be the best one. But you have to focus on this design for long. And you can see this vertical geometry here. Go to profile view properties, and this is the time to change these things here. What is this? FRL, finish road level, you have to give FG. And this one, VGO, vertical geometry, that is again you have to give FG, and press apply and press OK. Now you can see here it is shown the K values. This is bit different, right? It says it's crest and sag everything. So you have to check your K values. Okay, for 50 kmph for the crest, how much do you want to take? Is it 12? I think 12. How much? 12. Yeah. For the sag, is it 18? Huh? Sorry? Same 12. Yeah. 18 is for 60, isn't it? Sorry? 9.9. Cannot be. Sag cannot be less than the crest. How much? 9.9. For the crest vertical curves, it is 9.8. Sag 12. Then okay. Now you can see that they are being satisfied here, but of course there is one thing that you have to do. You have to check whether you can improve this profile. How? For that, what you can do is you can go to profile view properties, and here So maybe you can go to elevation and stations and add, and you can give FG and here EG. We see you have to check what you are getting, right? You can go, sorry, you can go to profile view properties. What do they have in elevation and stations? Here you have to go to band details and major station. Now okay, I'll do it from the beginning, huh? Please pay attention here. Now what I do is I'm going to add elevation and station here, right, and then I am going to modify it right here, and this in major station I go to compose label, and I am going to give eg fg is only true. I am going to give profile, it is there, it's already there, right? Profile 1 elevation minus profile 2 elevation, it's already there, so you don't want to change anything. Okay, only you have to change here is fg profile 1 minus profile 2. So we'll take this up, giving some minus 100, but remember this one is wrong, right? You have to give fg minus recamber. Okay, say I'll give here something like 120 to take it bit up. Now you can see, now uh, here you can see, if you consider here, now of course it is 0.03072. Now you can see that here you can lower this by zero point 0.3 without any problem. Okay, so once you are happy with your the shape of your finished ground profile, what you can do is you have to fine tune it. Okay, so you can reduce this by say 30 millimeters, that is 25. Now see, again you can reduce it by another 20, another 30. Say, still you can another 8. We'll say 80. Again you can 5. We'll reduce it by 10. Now okay, 0. Here also it's minus 11, minus 12, you can't change. Okay, minus 26. Then of course you will have to uh, take it up a bit, say 8, 10. Like that. Okay, so you have to correct this. Correct in the sense you have to fine tune it. Now what are you supposed to check? One thing is K value, other one is the VCL, of course, that you have given as 50. Then you have to check the K value, then you have to check the slopes, and then you have to fine tune this as much as possible to match with the your recambering profile. That's all. Okay, so at the end of this you are getting your final profile view or the final profile. Understood?